Welcome to Spring Lib.
Okay, we need to answer what transition in a hydrogen atom requires the largest change in energy. Well, recall that the change in energy, is proportional to 1 over n1 squared minus 1 over n2 squared, right? So whatever the largest difference in n1 1 over n1 squared and 1 over n2 squared is going to be our answer, right? So let's go through these options. We've got n1 equals 2, so that's 1 over 4, and n2 equals 4, so minus 1 over 16. B, we've got n1 equals 1, so 1 over 1, minus n2 equals 3, so that's 1 over 9. For C, we've got n1 equals 1, so that's 1 over 1, minus n2 equals 2, so that's 1 over 4. And D, we've got n1 equals 9, 1 over 9 squared, so that's actually 1 over 81, minus n2 equals 10, so that's 1 over 100. And we do have an E as well. So E is n1 equals 2, so that's 1 over 4. And n2 equals 3, so that's 1 over 9. Okay. So really, if we just compute these, we could just pick the largest. I could say there's kind of an obvious one that's going to be the largest. Right, this is 1 minus 1/9. This is 8/9. Right, that's nearly close to 1. Right, the largest you could possibly get would be 1 over 1 minus 1 over infinity, which would represent the dissociation entirely of an atom after having been in the n equals 1 shell. So this would effectively just be 1. And this is the largest transition you can get. That's the biggest gap you can possibly get. I'm going to guess that 8/9 is probably the biggest one of these. B is the answer, but if you want to be absolutely certain, what have we got here? We've got 4/16 minus 1/16 equals 3/16. 1, so this is 4 over 4 minus 1/4 equals 3 over 4. This is just small. It's not worth computing, not worth putting over a common denominator. It's just not this one, right? 1 over 81 is already way smaller than 8/9, and we're going to subtract something from it. So next we've got common denominator of 36, I suppose. So 9/36 minus 4/36 is 5/36. Right. And as predicted, yeah, this is going to be the biggest energy change. You can also just say, okay, we're going from level 1 to level 9. That's a fairly large gap. And remember, going from 9 to 10, right, that's a small gap. Well, I guess what I'm trying to point out is the larger the ends get, the smaller the gaps between the ends get, right, until they basically just bleed together. Point being that a large energy difference is usually going to have to include a low n level, right? So this is basically what we did, that gap right there.